Hello, everybody. We're doing the revision of section 1.1 of physics, which is about physical quantities and measurement techniques. Physical quantities and measurement techniques. And measurement techniques. And we'll take a brief overview. And this, by the way, this does not include the vectors. We'll cover vectors sometime later. Instruments for measuring length. There are three instruments. Of course, there are a lot of instruments which we use to measure length, but primarily there are three instruments which are part of your syllabus. And those are, number one is meter rule. Then there is measuring tape. And then there is um, micrometer screw gauge. We also call it the micrometer. We also call it the screw gauge. These are the three instruments that we that are part of the syllabus that we will use for measuring length. Of course, there are a lot many. Meter rule has now each instrument has its specific purpose, and each instrument has its specific accuracy and precision. Accuracy and range. Accuracy means the minimum length it can measure, and range means the maximum length it can measure. So the accuracy for meter rule is the smallest length it can measure is 0.1 centimeters, or I would say 1 millimeters, uh, 0.1 centimeter, or I can say 1 millimeter. Same is the accuracy for measuring tape. It's either 0.1 centimeters, or you can say it's 1 millimeters. And the accuracy for micrometer screw gauge is 0.01 centimeter, actually 0.001 centimeter, or I can say 0.01 millimeter. So this is the accuracy that you need to remember. This is the smallest measurement it can take. For the greatest measurement it can take, it's called the range. So meter rule, I mean, as the name suggests, the word meter means its maximum length is 1 meter, so it cannot go beyond 1 meters. So the range is simply 1 meter, or in terms of centimeter, I would say it's 100 centimeters or 1 meter. For measuring tape can go as long as to 100 meters, right? So it varies. A few meters, I would say, but there is no specific range for measuring tape because measuring tape comes in different sizes. And for micrometer screw gauge, because it's a very accurate instrument, it gives you a very small measurement as well. Like, for example, you can measure thickness of your hair with the micrometer. So the range is going to be uh, approx 2 to 2.5 centimeters, not more than that. Okay, then we have instruments for measuring mass. There's two instruments that we normally use for measuring mass. The one is physical balance. I'm sure you've seen that. When you choose two masses to compare, you use the comparison of the masses to measure the mass of the unknown object. And then there is a top band balance, or I would say it's also called the electronic balance. Electronic balance. Instrument that we use for measuring volume of a fluid is a volume, I would say, of a fluid. And by fluid, I'll be specific, of a liquid, is measuring beaker, right? Or a measuring cylinder to be precise, not a beaker. Measuring cylinder. I'm sure you've seen a measuring cylinder. It looks something like this, the one shown below. There's a very important concept that is normally part of the exam, and that is volume of how do you measure the volume of an irregular solid? For example, here is an irregular solid, and you want to measure its volume. How would you do that? First things first, you would pour some water into, or you can pour any fluid, not necessarily water. You can pour any fluid in the volume in the beaker and take its reading, V1. Then you put the solid in the beaker. For example, I've put the solid in the beaker, and of course the volume rises. You would take record the final volume, and I'll call it V2, and the volume of the solid is going to be V2 minus V1, and the process is called displacement method. Displacement method. Right. Then we have some physical quantity, scalar physical quantities. Like there are two branches of physical quantities, scalar quantities and vector quantities. I'm not going to get into too much detail. Of course, this is a revision. So scalar quantities are those which only have magnitude only, and you can say no direction. I'm just writing the hinting words, not the exact definition. And vector quantities are those which have magnitude plus direction. So they have a direction alongside the magnitude. There's some examples of scalar quantities that you need to remember initially. Those are distance, time, temperature, and here there's a bunch that you need to know. Distance, time, temperature, length. I mean, length would be the distance. Length and distance are the same. Energy, that is one, and so on. There are a lot. And we have some vector quantities. For example, force is a vector quantity, right? Weight is a vector quantity. By the way, speed is a vector scalar quantity as well. We have speed as a scalar quantity. As opposed to speed, we have this. As opposed to distance, we have displacement, and as opposed to speed, we have velocity. And acceleration is a vector quantity. The two vector quantities that you need to know: gravitational field strength, for example. Gravitational field strength, that is a vector quantity. There is something else which is called electric field strength. That is a scalar quantity, and so on. For example, force, velocity, acceleration. Have I mentioned acceleration? Yes. Force, weight, velocity, acceleration, and so on. I mean, there are a lot. Those are all vector quantities. Okay, now we're finally starting with the past paper questions. Let's see. Before marking the finishing line on a running track, a groundsman measures out its 100-meter length, and the 100-meter length is measured as which instrument is used for this purpose? Micrometer, the range of the micrometer. I want to measure a 100-meter distance, right? The range of the micrometer is from 2 to 2.5 centimeters, right? It cannot measure any length which is bigger than 2 to 2.5 centimeters. So I will immediately take out micrometer. 30-centimeter ruler would also not work because I want to measure 100 centimeters, which is a lot bigger than 30 centimeters. Meter rule is the length of the meter rule is 100 centimeters, right? Or 1 meter, which is not going to work. So measuring tape um, is the instrument that I will use. A measuring cylinder contains 20 centimeter cube of water. A stone is placed in water and the water level rises to 38. So this is the initial volume, 20 centimeter cube, right? So for example, V1 is 20 centimeter cube. And after you put in the stone, the volume rises to 38 centimeter cube. What's the volume? Of course, you will have to do V2 minus V1, which is going to be 38 minus 20, which is going to be 18 centimeter cube. So 18 centimeter cube is your answer. Next, what is the reading on the stopwatch? This is instrument we use to measure time. So this is 30, right? And this is 40, right? Because 30, this is 35, 40, and 45, right? So which means every single unit is 1 second. So 31, 32, 33, 34, and there is 35, and this one should be 36 seconds. So the answer is going to be 36.0 seconds. A student walks at a constant speed. This one is interesting. You'll have to take some time to think about it. A student walks at a constant speed. He takes 100 seconds to walk 160 paces. Paces means like the amount each step, I would say, 160 steps. The length of each pace is 0.8 centimeter. How far does the student walk in 50 seconds? Okay, so this is time, and this is paces, and this is the distance. When the time is 100 seconds, right, paces would be 160 paces. And of course, each pace is 0.8 meters. So you would multiply 0.8 by 160. Okay, 0.8 meters. Distance of each pace is zero point 0.8 meters multiply. I'm not going to write meters. I'll just multiply by 160. Now, this is not what we're after. How far does a student walk in 50 seconds? So I'll divide everything by half because 50 seconds, uh, 50 is a half of 100, right? So how many paces would he cover? He would cover 80 paces, right? And this distance would be zero point 0.8 times 80. And that is going to be zero point 0.8 times 80. Let's work it out. I think 64. Let's see. Zero point 0.8 times 80. It's going to be 64 meters. Okay, I hope it makes sense. Next, during an experiment, to find the density of the stone. Density, basically the formula for density is equal to mass divided by volume. Lowered into a measuring cylinder, partly filled with water. So this method is called the displacement method, and we use the displacement method to find out the volume. Okay, it doesn't give us density; it only gives us the um, it only gives the volume of the stone, right? So the difference between the readings, which means if the reading is V1 and if the reading is V2, then the difference would be V2 minus V1, right? So difference gives you the volume, not the density. So difference between the readings give you the density, therefore the answer A would be incorrect. Let's look at answer C. The final reading gives you the density of the stone. That is also incorrect. The final reading gives you the volume of the stone. The final reading does not give us the volume, the difference between the readings. So the volume of the stone will be equal to V2 minus V1, and um, it gives us the volume of the stone, not the density. And the difference gives us the difference between the volumes gives us the volume of the stone. Okay. This is shows the micrometer scale. So how do we measure? How do we work out the main scale reading? We use the main scale reading and we add it. We'll take the circular scale reading. CSR means circular scale reading. We multiply it by 0.01. Okay. So in this case, the main scale reading is 0, 1, 2, 3, 4, 5, 6, 7, and this is going to be 7.5. Main scale reading is 7.5 millimeters. I'll write millimeters by the very end. If you follow the circular scale reading very, very carefully, let's see. Circular scale reading is going to be, so this is 10, 11, 12, 13, 14. Circular scale reading would be 14. So CSR is going to be 14. I'm going to have to multiply 14 with 0 0.01. 0 0.01, it becomes 0 0.01, 0 0.14 actually. I'm going to add both, so 7.5 plus 0 0.14. If you were to add them, I'm sure you know how to do the decimal addition, or you can do it in the calculator as well. 40 and 7.64 millimeters is your answer. Which quantity is a vector? Energy is a scalar quantity, speed is a scalar quantity, time is a scalar quantity, force is a vector quantity. A car's acceleration and maximum speed are improved by using an engine of a smaller mass and greater driving force. How many of the underlying quantities are vectors? Well, acceleration is a vector quantity, speed is a scalar quantity, mass is a scalar quantity, and force is a vector quantity. How many of them are vectors? 1 and 2, two vector quantities. A pendulum swings with the time period of approximately 1 second. Describe how to use a stopwatch to determine the time period of the pendulum. So this is basically measuring small intervals. This is the belongs to the concept of which we studied earlier, measuring small intervals. So measuring small intervals basically is, for example, let's say you want to measure, let's say this is a pendulum, right? And pendulum swings and goes all the way up here. So pendulum swings in this direction and it comes back in this direction, right? And one time period is when it when it takes one complete cycle. This is called one complete oscillation. For example, it takes 1 second or approximately zero point 0.9 seconds. Then how would you measure the small interval? Now, the problem with measuring small intervals is that it's really difficult because the human response time is very, very small. So what we do is we do not take a single reading, but we take 18 to 20 readings, more than one readings, and we divide the bigger number by the number of readings. For example, I would take 18 readings. I would take 18 oscillations, right? Let's say I would do 20 oscillations. For example, this is an example. Do not write this in the exam. For example, you do 20 oscillations, and the time period for 20 oscillation is 18 seconds, right? This is a time period for 20 oscillations, not one oscillation. How would you work out the time period for one oscillation? Time period would be equal to 20. You divide that by total. You take the time, I'm so sorry, you take the time period, 18 seconds, you divide by the number of oscillations, and you will get something like, for example, zero point 0.9 something seconds. Okay. So how would you describe it in 3 marks? How would you use a stopwatch to measure the time period of the pendulum? You would say, well, uh, uh, take, record, I would say record the time period, record the time for 20 to 30 oscillations, maybe, right? And um, record the time for 20 oscillations and then divide the total time by the number of oscillations. That's it. I think this is a very simple formula, or you can say, or you can write the formula if you want. Time period would be equal to total time divided by number of oscillations, and this will give you the time period. I can write it as time period. By time period, I mean the time for one oscillation. Time period is equal to total time divided by number of oscillations. Next, complete table 2.1 by writing in each space on the right-hand column which one of the following devices is used to measure the quantity in the left-hand column. Okay, volume of water in glass, of course, we just talked about this. Instrument for measuring volume is measuring cylinder, right? I will write this. Measuring cylinder. Width of a small swimming pool, and because it's a small swimming pool, I cannot use micrometer screw gauge because the range is very, very small. I would use meter rule. This one, I would use meter rule. Thickness of a small aluminum foil, again, we use micrometer screw gauge to measure the really, really small thicknesses or lengths. State what is meant by mass. Well, amount of matter in a body, or substance. This is called mass. State the name of the instrument that you use to determine mass. We just saw two instruments. You can write any one. You can write physical balance, or you can write top and balance. It's totally up to you. Top and balance. Okay, the following statements are about motion. Which statements describe vector quantities? A plane flies due east for 600 kilometers. So this is the distance and this is the direction, right? Magnitude and direction. So this one is going to be a vector quantity. And average speed, we know that it's a scalar quantity, right? Around the track is 5 millimeters per second. So this is a scalar quantity, right? A snail crawls 3 millimeters per second in a straight line towards letters. So this is the magnitude and this is the direction. Once you have magnitude and direction, this one is just magnitude. If you have magnitude and direction, this is a vector quantity. A tourist travels 500 kilometers on a journey. You only have magnitude, you have no direction. So this is a scalar quantity. Which of the scalar quantities? 2 and 4. So this would be your. No, wait a sec. We're talking about vector quantities. Vector quantities are. So sorry. These are vector quantities. First one is a vector quantity, and this is a vector quantity, and this is a vector. 1 and 3. There you go. Which list contains scalar? Only scalar quantities. In the first list, you have acceleration as a vector quantity. I'll cross out A. In the second list, force is a vector quantity. Because we're only looking for scalar quantities, I'll cross out B. Force again is a vector quantity, so I'll cross out C as well. Length, mass, speed, all of them are vector quantity. Sorry, all of them are scalar quantities. So D would be your answer. Which pair of quantities include one scalar and one vector? This is a scalar, this is a scalar. We're looking for one scalar and one vector. I'll cross out A. Temperature and time are both scalar, so I'll cross out B as well. Temperature is a scalar, velocity is a vector, so C would be my answer. Velocity is a vector, weight is a vector, they're both vector quantities. I'll cross out D as well. Which row shows the examples of vector quantity and a scalar quantity? Area is a scalar quantity, mass is a scalar quantity, so A and B are out. Velocity is a vector quantity, but again, acceleration is also a vector quantity, so I'll cross out C as well because of this. Weight is a vector quantity, volume is a scalar quantity, so A would be your answer. Velocity is given by change in displacement divided by change in time. How many vector quantities appear in this statement? First vector quantity is velocity. This is the first one. And the second one, velocity. The second one is displacement. Time is also a quantity, but this is a scalar quantity. We're looking for vector quantities in this statement. There are two, so the answer is going to be C. The level of water in the measuring cylinder is 75 centimeter cube. So initial volume is 75 cm cube. If you put in a stone of 20 centimeter cube, the volume rises up to, of course, the volume rises up to 75 plus 20, which is going to be 95 centimeter cube. 95 centimeter cube will be your answer. I hope it makes sense. I hope it gives you a good revision of worksheet 1, physical quantities and measurement techniques.